Okay, this is my DIY pool heat pump. I'm only doing it in one direction right now, heating. I usually don't need to cool in the summertime, so this is what I have built. This is actually a recycled home condenser compressor from a home central air unit that I salvaged when we replaced our home AC. And then this is this same interior coil, whatever you call it, evaporator from inside the house. Got the dryer from a friend in town here, Baxter Comfort Solutions. If anybody needs a plug for them, good people. I'm running it off of propane, or 960 or whatever you AC people call it. Propane, that's what it is. I'm actually using a compressor to vac down the system. I'm just hooking a port and valve up to the inlet side. By the way, if a lot of people want to quiet down your compressors, do something different with the intake, because this thing is almost silent now. Run it outside or put a muffler on or something. But so I'm running that through nylon tubing. This allows me to vac down the entire system. Once I get it vac down, I open up the bottle of propane, start dumping that in. This was probably the hardest plumbing part to figure out, because I had to find this specific one. This is from Harbor Freight, comes as a part of a propane torch kit, but it has a 1/8" MIP fitting on it, so I just adapted that. Also, I've been struggling with compression fittings for the last couple of days. They're just ridiculous, but I actually figured out that if you have one that's constantly leaking, like this one was, you can actually turn them into solder joints. So I did that, and that's holding 250 pounds, so that's pretty good. But I use this valve here to shut off my inlet pressurizing side, so I can eventually shut this off, disconnect everything, and install it. It goes to a low pressure side gauge right here, which goes up to my inlet. Essentially, this is where the circulation goes, is through here. So it goes from the compressor inlet side over here, gets pressurized, high pressure gauge at the top here. That goes around to my heating coil, which is essentially right now just this guy here. I have a thermocouple hooked up to that. Currently it's at 87 degrees. And then once it goes through there, it comes around through another fitting that I've been having problems with that I'll eventually turn into a copper fitting, or a solder fitting. Goes around here, through this line here, goes to the dryer. And this little tube right here is the magic of the whole system. So most systems have a valve that keep the high pressure side high and the low pressure side low. But what I did was, this is called a capillary tube, and you can find calculators for what size and diameter and length to make these online. But essentially what this does is restricts the flow of air from the high side to the low side and creates that pressure differential. So then from there it goes through this tube here, goes into the evaporator coil. On the underside, so I got this sitting on top of a speaker right now, but eventually this is going to be like my pallet base, and I'm going to build a nice aesthetically pleasing shroud for this. But the airflow essentially goes in from this direction and from the back, and goes down, and I just I cut a hole and put a fan through there, so it's got a fan motor there, set it on high. And then the electrical of it is all original from the AC installation, so I just use the original capacitor. It is a 220 motor, so this is a let's see, I think it says on here 30,000 BTU, 2.5 ton AC unit. And then I just hooked it up to 220, plugged in right there, and I'm just controlling it with the breaker there. I just hooked it up to the same breaker that I charge my car off of, so I can test. Once everything is installed, and I take it out to the pool and I install it, this will sit as a pallet next to my pool filter. And then this, right now, my plan is to put that in the skimmer basket. But if that doesn't work, I'll build a heat exchanger that's in line to get the heat transferred. So I'm going to turn this on, and we'll keep an eye on, actually, really the result that we're looking for is heat, right? So this thermocouple is attached here. We're looking at 67 degrees. going to turn it on. It may be a little noisy, but hoping you can hear me over this. So kick on the breaker and the fan. I'm going to turn those two on. So the system is not that loud. If you've ever stood out next to your AC system for your house, for your central air, it's the exact same amount of noise. Once I put a shroud over it and I get a little bit of sound dampening inside, it'll actually be quieter than the pool pump will be. So that'll be good. Shouldn't have any extra noise pollution from that. So the system's working. I have this blanket over it because my fan underneath was blowing cold air across my coil, so I want to separate those two. Unfortunately, they're right next to each other right now. So looking at, I'm hoping you can see that, we're up to 97, 98, 100 degrees on the coil right there. So this will sit inside the skimmer basket and transfer the heat so that the gas going back, the propane going back, will be cooled off before it gets condensed again. Look at that, 117 degrees, 115. 120. Our goal for the pool is about 80 degrees. We want to be able to use this in the early or in the late spring and the early fall. There's 120. To be able to just extend the swimming season a little bit. So if we can get 80 degrees, if I can even get 75 degrees, it'll make the wife and kids happy to get in the pool. But yeah, there's 130. There we go. And it's actually climbing because I'm still adding propane to the system. So you can see I'm building up a lot of condensation, a little bit of frost on there. Almost 245 PSI. And we're about almost a 20 on the low side, so it's definitely working. We're getting state change of the propane. Between liquid and gas, and that's essentially what's doing it. So that's 150 degrees. Look at that. We're almost up to the capability of a gas or a propane pool heater right there. So yeah, that's the redneck way to do a pool heat pump. And the whole reason for this is heat pumps actually operate at about 30% more efficient than LP or natural gas will operate at. And LP, I mean, if you've looked at the price of LP or natural gas right now, you could imagine what it would cost to dump that into a pool that's uninsulated. I mean, you'd be constantly doing that. So this basically consumes about 10 amps to do the exact same thing at even more efficient. We're at 176 degrees Fahrenheit there, 175, so definitely doing its job. I'm not going to touch that anymore. That's going to be, maybe on this side it's probably cool enough, but nope, that's hot. Yeah, let me know what you guys think.